Okay, so let's look at this example. Again, this is an example on recognizing a conditional probability. So it says a blood test indicates the presence of a disease. 95% of the time, the disease is actually present. Okay, so here I am going to let D denote the event that someone let's let D denote that someone has the disease, and let's take P be the event that someone tests positive. Then what is the 95% here? Well, that's the conditional probability, the probability of what? So the 95% is what? 0.95. It is it P given D or D given P? It's the probability of bad notation. Let me, because I'm using P to denote probability, let's use something else here. What other letters can I use for tests positive? I'm sorry? B?
Yeah.
U? See? Okay. How about I use something like T and P? So it's the TP given D. All right, so let's look at another example. Let's say there is an insurance company, and the insurance company believes that people can be divided into two classes. Those people are those drivers who are accident prone and those who are not accident prone. Okay. Apparently, if your age is above 25 and if you are married and if you have child, then you are in the second category. Okay, so the company has obtained some statistics. Well, first of all, let me give you a few seconds to write down this. Okay, so the company's statistics, number one, an accident-prone person or driver will have an accident at some time within a fixed 1 year period with probability 0.4. An accident-prone driver will have an accident at some time within a fixed 1 year with probability 0.4. Whereas this probability reduces to 0.2 for a person or a driver who is not accident prone. So in other words, the probability, in other words, the probability that a driver who is not accident prone will have an accident at some time within a fixed 1 year is 0.2. And it's another information here is that 30% of the population is accident prone. Okay. All right, so the question is, what is the probability that a new policyholder will have an accident within a year of purchasing a policy? What's the probability that a new policyholder will have an accident within a year of purchasing a policy? Okay, so that's the question. Okay, so how are we going to answer that? Well, let's label some events before we answer the question. So let's let A denote the event that a driver or a policyholder will maybe let me be more specific. A driver, a policyholder will have an accident within 1 year, and B be the event that a driver is accident prone. Okay, what is B complement then? What's B complement? The event that a driver is not accident prone, right? Okay, so what is the question asking us to find? What are we supposed to find? We are supposed to find the probability of A. Is everybody clear on that? So remember, the question was find what is the probability that a new policyholder will have an accident within a year. So that's the probability of A. So we need to find the probability of A. And how are we going to find that? So what's given in the question? Number 1 said what? Can somebody express number 1 as a probability? Yeah. Wait, don't give me that. Oh, just number 1, the fact number 1. You remember the 3 statistics from the company? Yeah, so I can express that as a probability. So what is that? That's the probability of A given B, right? Probability that a driver will have an accident within a year, given that he is accident prone, right? That's number 1. So I can say, so what are the things that are given? The things that are given is, what's the probability of A given B? And that's given to be 0.4, right? What else is given? Oh, what is expressed by, if you look at the list of statistics, yeah. The probability of A given B complement, that is the probability that a driver is going to have an accident within a year, given that he is not accident prone, right? And that's given to be what? 0.2. B complement. And then what else do I know? We know the probability of B, that is the probability that a driver is accident prone is 30%, isn't it? So 0.3. So that's the last of the statistics from the company. So these are what we are given. So how can I find the probability of A? Yeah. Yeah, we are using what rule? This is known as the... No. This is known as the average rule, right? The overall probability of A, B and B complement constitute a partition of the sample space, right? So overall probability of A is the weighted average of the probabilities of the conditional probabilities of A with respect to B and B complement, where the weights are the probabilities of B and B complement. So this is going to be equal to, then, we know all the numbers here, right? A given B would be 0.4, 0.4. The probability of B is 0.3. Probability of A given B complement is 0.2. What's the probability of B complement? 0.7. Okay, what do you get? 0.26. Last problem. In answering a question on a multiple choice test, a student either knows the answer or he guesses. In answering a question on a multiple choice test, a student either knows the answer to a question or he guesses to answer the question. We're going to denote by P the probability that the student knows the answer, and 1 minus P will be the probability that the student guesses. Okay? P is the probability that the student knows the answer to a question, and 1 minus P is the probability that the student will guess to answer a question. Okay? So given a question, either he knows or he guesses, okay? Assume that the probability is 1 over m, that a student who guesses at the answer of a question is correct, where m is the number of multiple choice alternatives. So if you have a question with m alternatives, then if you have a question with m alternative answers, then the probability that a student who guesses at the answer of a question is correct is 1 over m. Okay. What's the probability? The question is, what's the probability that a student knew the answer to a question? What's the probability that a student knew the answer to a question given that he or she answered it correctly? Okay. What's the probability that the student knew the answer to a question given that he answered it correctly? Okay, let me know when you're done writing it down. So you have a test where all the questions are multiple choice questions, and for each question, either you know the answer or you don't know and you guess. The probability that you know the answer is p, and the probability that you don't know the answer is 1 minus p, or the probability that you're going to guess is 1 minus p. And so when you guess, if you have a question with m alternative answers, then the probability that you are going to be correct is 1 over m, right? Because you have m choices. So you're going to randomly choose one of them, right? So the probability that you're correct when you guess is 1 over m. Okay. So the question is, what's the probability that you know the answer to a question given that you answered it correctly? All right. So everybody understands the question. So let's label a couple of events. Let's let K be the event that the student knows the answer, knows the answer to a and let's take C to denote the event that let me just say answers correctly. So this is the event that the student answers a question correctly. Okay. What are we given? We are given that the probability of K, the probability that he knows the answer, is P, right? And what else do we know? We also know the probability that he doesn't know the answer and guesses is 1 minus P, right? What is asked in the question? We want to find the probability that he knows the answer, right? Probability that he knows the answer given that he answered it correctly, right? Isn't that what let me double check. Yeah. What's the probability that he knew the answer? So this is what we want to find. I need to make some space. Okay, find this. So how am I going to find this? The probability that he knows the answer to a question given that he answers it correctly. Okay. What do we know? What are the things that we know here? Do we know? So let's see. Do we know the probability that he knows the answer to a question do we know the probability that he answers a question correctly given that he knows the answer? Do we know that? Do we know the probability that he answers a question correctly given that he guesses or he doesn't know the answer? Do we know these two things? What is the first one? The probability that he answers a question correctly given that he knows the answer. Yeah, that's one. What's the probability that he answers correctly given that he doesn't know the answer and he guesses? That's 1 over n, right? Okay, so what rule should I be able to use here? The probability of k given c. You see, I need to find k given c, but I know the probability of c given k, right? The opposite. So that's an indication that maybe I should be using what? Bayes' rule. Bayes' rule says this is the same as the probability of c given k times the probability of k divided by the probability of c given k times the probability of k plus the probability of c given k complement times the probability of k complement. And okay, so now we plug in the numbers. So what is p of c given k again? What is p of k? 1 times p plus, what was p of c given k complement? And what was p of k complement? 1 minus p, right? Okay, so I guess you can do the simplification, arithmetic, and what you should be getting at the end is np over np plus 1 minus p. Unless I made an algebra mistake. That should be the answer, okay? Okay, so you can check, you can do the algebra and check that. Now, because of the time, I won't do this example. Instead, I'm now going to stop